Blake Ash, and today I will be giving an informative speech on electrokinetic remediation. Now, what is electrokinetic remediation? It is a process of using direct electric current to remove organic, inorganic, and heavy medical particles from the soil using electric potential. Now, this is a setup of how this would normally be done in the field. Now, you're going to be drilling holes, little boreholes, a couple feet down into the ground and filling each one of them up with water. From there, you stick in electric rods, each one having a different electrical current, one negative and one positive, an anostroke and a cathode. From there, what happens is the water is going to be going through the soil to each one because it has a charge, and it's going to be attracted to each one of these based off the charge. As it moves through the soil, the water is going to pick up any kind of particle that's in there and move out through the soil. And then all your contamination right here in this area is going to be moved into here, and after you remove the water, your contamination is gone. Now, it has its advantages and disadvantages. Some of its advantages is the process can actually be targeted to a specific area, which means it's just going to happen in between the area of where the two electric rods are at. Another advantage is the fact the soil does not need to be removed, meaning the only thing that's going to be removed is the boreholes, and the soil is just going to be replaced. Another advantage is the technique is applicable for a wide range of contaminants. Water is going to soak up and combine with all these contaminants and move through the soil. Now, some of the disadvantages it has is it does take this process a very long time depending on the type of soil. If it's like a sand, the water is going to move through the sand pretty quickly because the sand, the particles are not close together. But with a soil like a clay that has a high resistance to water permeability, it's going to take a lot longer for that water to get through to get to those contaminants. Another disadvantage is if you have some kind of object or obstruction in between those two holes that water would have to move through. Say if you drill your two holes and then you have a piece of sheet metal or something or a big rock in between, it's not going to work because that rock's just going to stop the flow of the water. Another effect is that they have to kind of have a general idea of what kind of contaminants are there. There's some contaminants that do not work with this kind of remediation. So if they go in and don't know what kind of contaminants are in the soil, then this process may not even be effective at all. Another disadvantage is that the electrodes will actually change the pH of the soil. So if you're in a very specific area that grows very specific things, it can change the soil pH and make it unusable for that type of plant or something. So again, this is kind of the field setup that would be required. You'd have to have a power supply for the electrodes and stuff like that. And then you'd have to have a certain amount of power, which ranges, depending on what kind of contamination it is, from 50 to 250 kilowatts. The usual distance between these holes are 2 to 7 feet. You don't want them too far because the further they get, the more power you got to have, the more cost. Ceramic wells normally go in to prevent erosion and stuff like that, to keep the walls up depending on what kind of soil you have. So if you have sand, you got to use something like that to keep the walls up so they don't collapse on themselves. And the cost normally varies depending on the soil, depending on how much time it takes. 25 to 225 cubic yards. This is a case study that I actually looked at. This is from the U.S. Department of Energy and Patoka Gaseous Diffusion Plant in Patoka, Kentucky. Now, this places the first nuclear weapons program in the United States. They began enriching uranium in 1952, and this caused, over the 50 years, this caused contamination from uranium and radioactive material to get on the site. So they went in and did this type of remediation. They split it into 4 treatment zones to where it had depending on how much was in that area. So they had some areas where they didn't have to use a lot of the electrodes, so they just had them at wide ranges to split up the cost. And then the results of this remediation was very effective. They used a 2.25 volume per centimeter moved through the water at a speed of 0.43 centimeters per day, which is not very much. That's why this takes a long time. But the overall efficiency of this was 99.7% of the contaminants removed from this site. At the end of this, the cost ended up being about $80 per cubic yard. And this is my works cited. Thank you for listening to me. Have a good day.